Hello and welcome back. We're going to continue our discussion with the 2014 AP exam. So let's take a look at question number 2 for right now. Number 2 says the graphs of the polar curves r equals 3 and r equals 3 minus 2 sine 2 theta. So of course r equals 3 is this circle that we have right there, and this 3 minus 2 sine 2 theta is this weird kind of propeller or flower looking thing. It's the other one right there. Are shown above, and we're only looking at the domains from 0 to pi right here. Okay, so question 1, it says let R be the shaded region inside the graph of the circle and inside the graph of that weird thing right there. So it looks like it's that shaded region. It's the common area. We want to find the area of R. So when I look at this right here, one is the area of a polar formula. So if you forgot the area how to find a polar, remember it's this 1/2 the integral from a to b, and that's going to become r of theta squared d theta. I have another video on that if you want to take a look at that. Please go and click on that. So what we're looking for is this region right here. So if I take a look here, we're going to find the area between 0 and pi. So we want to go from 0 radians all the way to pi radians. Now if you remember, when you measure with polars, we don't measure horizontally or vertically for area, like so, like vertically or horizontally. We measure from the pole or the center, and we rotate around that center right here. So when we start measuring it from the pole outwards, and we're just going to kind of measure along this path, and we're going to kind of trace out our polar graphs. Now if you notice, though, between 0 and pi over 2, we are only on this one right here, this weird flower type of shape. And then from pi over 2 to pi, we are on the circle. So if I want to write this out, I would take the area of this weird one, of this 3 minus 2 sine 2 theta, and I'm going to add to that the area of our circle, which has a radius of 3 right here. So I'm going to set up two different integrals for this expression, for this to find out this area. So let's take a look here. So the first one, our area equals 1/2. Remember, we're going from 0 to pi over 2, and that's going to be 3 minus 2 sine 2 theta squared d theta plus, now even though I know this is a quarter of a circle, I'm not thinking, I'm just going to get the answer, 1/2 pi over 2 to pi 3 squared d theta. And there's our expression. So now we're not done yet, because they do tell us to find the area. And they do not want you to do this by hand. This is a calculator question, and the rule says if they use a calculator, we're going to go ahead and use it. So I'm just going to type in exactly as it looks. So we can go menu, 4. I'm looking for an integral. Now I do want to put this 1/2 on the outside, 1/2 times this integral. My first one goes from 0 to pi over 2, 0, pi over 2, and I'm going to type in that expression. Make sure you are in radian mode before you type in tricks. 3 minus 2 sine 2 theta. Now I'm going to use 2x here because it's just easier to find than looking for that theta. Make sure it matches up, and on the outside, all the way on the outside, square that. Dx, go on, click out, and we go plus 1/2 times this little area right here, menu, 4, 3, and this becomes pi over 2 to pi, and 3 squared is just 9, whoops, got out of that, dx. And if we press enter, we should get our answer here. And it gives me this weird answer right here, 5 pi minus 6. You can write that out. Just go control enter, and you get the answer in a decimal, 9.708. Now they would accept the 7, of course, but we kind of want to round up here. And there's our answer. So how would they grade this on the AP? Very easy. Okay, you would have got 1 point for your integrands, just 1 point total for that, then 1 point for your limit. So basically your integrals are just 2 points, and then the answer is worth 1 point right there. All right, so for part B, the question asks for the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta. Now be careful, this is a rectangular question, but you got to remember we're in polar. So we have to convert rectangular to polar. Rectangular to polar. And we should remember how to do that. Remember we're converting polar to rectangular. That is terrible. There we go. We got to convert polar to rectangular because I'm given a polar graph, but I want to find a rectangular slope. So we have to convert. So we have to make x in terms of theta, and our rule is x is just r cosine theta. Now, even though I could take this derivative pretty easily by hand, they're letting me use a calculator for this problem right here. So I know that x will equal just r, which is 3 minus 2 sine 2 theta times cosine of theta. So there's my equation, and I want to find the slope at pi over 6. So I can now say dx d theta at theta equals pi over 6 is equal to, and I'm going to use my calculator to take that derivative. Remember, our calculator is very useful for a lot of skills, and one of those skills is taking derivatives for us. So I'll go menu, calculus. I'm looking for the derivative this time at a point, and I'm going to use x again, and I'm looking for the answer at pi over 6. First derivative is okay, and I could just type in my function exactly as it looks. 3 minus 2 sine 2 theta, or x here, go outside of that, times cosine of x. Make sure it's typed in okay. It's kind of hard to see there. There we go. Make sure it's typed in okay. Alright, my calculator is having trouble. There we go. And if I, yep, that's good. If I press enter, we got the wrong answer here. Hold on. Like that, so I press Control Enter, and we get this negative. Oops, let me see here. 2.366. I forgot to change my color there, but we all see an idea. So how many points would this be worth? You get 1 point for writing this out, writing out your expression, your conversion, and you get 1 point for your answer. So already we are at 5 out of the 9 points for the AP. This is worth quite a bit. It's pretty easy to get. All right, for part D. For part D, says we want the distance between the two curves. The distance between the two curves is only in the first quadrant. So I can write that out pretty easy. Before I do anything else, I'm just going to find the distance. So if I go up here to my graph, the distance between the two curves is this part. This is the distance I want from here to here. And I can get that. Notice, it's the circle minus that weird polar function. So I can write out my distance formula. We'll call it little d for distance is equal to the circle minus that polar graph, or 3 minus, whoops, that's not a minus, 3 minus, and this becomes 3 minus 2 sine 2 theta. And you can clean this up pretty easily. If you clean this up, the 3's are just going to cancel, and we're just left with, and distribute the negative, and we get 2 sine of 2 theta. So there is my equation for distance. And already, the AP is going to give you a point just for writing that out. Alright, so now look, we're at 6 points already. We want to find the rate at which the distance is changing with respect to theta. So we want to find the change in our distance with respect to theta. That's just our derivative. And that's just going to become chain rule for cosine 2 theta. And if you just plug in at theta equals pi over 3, we're going to get 4 times the cosine of 2 pi over 3, which is just 1/2. Or sorry, negative 1/2. So we have 4 times negative 1/2, and we get negative 2. And it's only worth 1 point because you can also just type that in your calculator if you get bored with it. You can type this in your calculator and get the same answer. This is just an easier derivative than part B, so I just want to take the derivative. All right, and then the last question for part D, it says a particle is moving along the curve at this rate, such and such a rate, so that d theta dt, sorry, that's not the rate, that's just the position, so that the rate of change of the angle is 3 at all times t is greater than 0. Find the value of dr dt at pi over 6. Now right away, I'm looking at this as a related rate. This is a related rate problem right here. So I just got to take the derivative. If I know r is this, I know dr dt is just going to become 0 minus, take the derivative of here, this becomes 4 cosine of 2 theta, don't forget chain rule, times d theta dt, and there's our derivative. And then we just plug in everything. So dr dt equals negative 4 cosine. If I plug in pi over 6, we just get pi over 3, and we know that d theta dt is just 3 here. And if we clean all this up, the cosine of pi over 3 is 1/2. So we get negative 4 times 1/2 times 3, and of course that just becomes negative 6, and you can probably get the units here. What is theta? R is whatever units, they'll give us the units, so we can just leave it as negative 6. So how many points would this be worth? Ready? Taking the derivative, 1 point. Getting your answer, 1 point. And there's 9 points. Alright, so I hope you enjoyed the video here, and we'll see you later. Come on back in, we'll take a look at part 3, question 3. Thank you.